In this topic, temperature, we'll be discussing about the variations of temperature with the increase in altitude. So objectives of this topic is gonna be what happens to the temperature with an increase in height, different ways through which our atmosphere temperature changes, diurnal variation of temperature that we'll be discussing about. It's a variation of temperature throughout the day, what is happening, how it is getting affected, that we'll be discussing, and the effects of the diurnal variation of temperature. I hope that in the previous topic that we have discussed, that is the atmosphere and pressure, that the questions you must have solved, the discussion session that will be scheduled to you all guys. Now comes the topic, that temperature. Now temperature can be defined in terms of what? It can be a hot temperature or it can be a cold temperature. How can we measure the temperature? The measurement of the temperatures, the units that we use into the aviation industry is the Celsius scale, the Fahrenheit scale, and the Kelvin scale. Now for the examination point of view, we will require to know the conversion between those things. So that is the Fahrenheit minus 32 divided by 1.8 is equal to Celsius. Then Celsius into 1.8 plus 32 is equal to Fahrenheit, and Celsius plus 273 is equal to Kelvin. So these are the formulas that are available on the screen. You will require to write it down on the left hand side of the book. It has also been available into the theory notes also. So you write it down on the left hand side, and further than that, we'll discuss more details about this Celsius scale, the Fahrenheit scale, and the Kelvin scale. Now these are the units that have been used for the measurements of the temperature. Now further than that, how do we measure the temperature? Exactly what kind of temperature we need to measure in our atmosphere, that we need to figure it out. So the measurement of the temperature, the units we got to know, the instruments that we use is this type of a instrument that is known as a Stevenson screen. Now the Stevenson screen is been made in such a way that it is at some height around 4 feet above the ground level. It has been a box, and inside that we keep the thermometer, where whatever the air will be flowing around it, that will be measured, because we need temperature to measure, that is the atmospheric temperature, and not the temperature that the solar radiations are coming to the ground. So we are supposed to keep this thermometer into this box that is known as the Stevenson screen. Further than that, another way through which we need to measure the temperature is the graphical representation of temperature. On the basis of graph, it will be presented, and this graphical representation of temperature is known as the thermograph, the instrument that we use for that. Thereafter that, we also need to know the temperatures at different altitudes and levels. So if I say for an example to calculate the temperature at 30,000 feet, how we are gonna get to know? Because these instruments cannot be kept at 30,000 feet above the atmosphere, right? So we are supposed to use the temperature, and the instrument that we use is the radiosonde. Now radiosonde is what? A thermometer will be fitted with a transmitter and receiver, which will be sending signals to the ground station wherever the receiver will be. Now the radiosonde, that instrument where the thermometer is attached with it, it has been kept into a balloon, meteorological balloon, that is known as, is used for the aviation industry, that is sent into the atmosphere. The speed at which it is going, we know it. We can calculate the distance, and then the ground station will be receiving the temperature. So via this way, we can calculate the temperature at different altitude. Suppose that there is another way we can calculate the temperature or identify the temperature at different altitude, is the pilot report, that is the aircraft report. From the aircraft to the ground station, we can tell them that we are flying at 30,000 feet, temperature at 30,000 feet is minus 15 degrees Celsius, or whatever the temperature you will be experiencing then. So that is what actual temperature you'll be able to send to the ground station. So these are the ways through which we measure the temperature on ground or at different altitudes, and the units that we use is degree Celsius, the Fahrenheit scale, and the Kelvin scale. Now in the atmosphere chapter, we also studied about saying that as we go higher and higher into the sky, the temperature is decreasing. So what it is, how it is, that we need to understand. Now whatever the solar radiations are there that are coming from the surface, from the sun, they are coming directly and hits the surface of the earth. But there are not all the solar radiations can reach the surface of the earth. There are many solar radiations which have been reflected by the clouds, or some of the reflecting material on the surface of the earth will be also reflecting the solar radiations into the sky. So that means what we need to figure it out, that only 30 to 40% of solar radiations are reaching the Earth's surface, rest all solar radiations are getting reflected back into the sky. Now this reflecting power is known as albedo. But whatever the rays that are coming from the sun, that are known as short wave radiations. And those short wave radiations reaching the Earth's surface, whatever the surface it reaches, it hits up the Earth's surface, and then the air above it will start getting heated up. Now the reflection of the solar radiation is important. Now that is known as albedo, that is a reflecting power. That means solar radiation reflecting power of any body is known as the albedo. Now albedo can be defined in terms of, if we talk about a fresh snow, a snowfall will be there. Snow can, whatever the solar radiations are coming, it will be reflecting all solar radiations back into the sky. That means it is not accepting any heat. That power of reflecting all solar radiations back and not accepting any energy, that power is known as the albedo. So a fresh snow will be having the highest albedo, then the old snow, and a grassland and a desert. Desert means what? Desert places. It will be accepting some amount of heat from the atmosphere, that is solar radiations, and heat up the surface also. If a dry earth will be there, it will be having less albedo. Wet earth will be there, it will be having little bit more less albedo. So albedo can be defined as high albedo or a low albedo. High albedo will be for the snow, that whatever the solar radiations are coming, they are all reflected back. While low albedo, that is forest or the dark pond fields or something like that, the solar radiations will be coming, all the heat will be absorbed, whatever is able to reach on the surface of the earth. So this is the albedo, that is the new terminology that you must have understood. I'll dictate the definition for that. You can write it down on the left hand side, that what is an albedo. I hope you all are ready, so I'll dictate the definition then. Albedo is the reflecting power or reflecting energy of solar radiation by the material. The greater the reflecting power or reflecting energy is known as high albedo, and less reflecting power is known as low albedo. You can just write down the statement into the book on the left hand side, that the book I have provided to you on the theory note. Post that, we need to understand albedo. After that, what are the different ways through which our atmosphere gets heated up? Now we have understood one thing, how do we measure the temperature of the air, but whatever the solar radiations are coming, they are hitting the Earth's surface and not the atmosphere. The Earth's surface, whatever is getting heated up, after that there are 4 different ways through which we can tell that the atmosphere is getting heated up, that the air around it is getting heated up. So conduction, convection, advection and condensation, this is known as latent heat condensation. These are the 4 ways through which our atmosphere gets heated up. I'll explain it to you. The first, that is the conduction process is what. Now conduction process is what? Whatever the solar radiations are coming, hitting up the surface of the earth, and the air which is in contact with it starts getting heated up, and that is known as the process that is known as conduction. Saying that if you touch any hot object, if you touch it, you are gonna feel warm. That is what the air which is in contact, that is the surface air, whatever it is in contact with the earth's surface, and the heat is being transferred via that process, and that is known as conduction process. So this is the first way through which our atmosphere is getting heated up, that is the conduction process is hitting the earth's surface in terms of whichever the air is in contact with the surface of the earth. Post that, the another method is the convection process. Now what is convection process? The air which is warmer, which was getting heated up on the surface of the earth, because of the earth which is getting heated up, the air molecules of the warm air is a lighter, because the density of warm air is less compared to the density of the colder air. Saying that, for an example, in a colder air the molecules will be very tightly packed, but in a warmer air it's not gonna be like that. It will be widely spaced because of some kinetic energy between those molecules. So air will start rising above and above into the sky. Air rising above into the sky starts warming the another area also at the higher altitude, and that is known as the process that is known as convection process. Air rising above into the sky, hitting the air surrounding to it at that altitude, and that is the process. Another way through which our atmosphere getting heated up, that is the convection process. The third way through which our atmosphere starts getting heated up is the winds blowing. advection process also it can be known as. So this process is what, from somewhere warm air is coming, hitting up the air around over here, and it go away, or a cold air coming. So this change in temperature is happening. This is the another way through which our atmosphere is getting heated up. Thereafter that, this is the last process, that is the condensation process. Now whatever the air is there or the water vapors are there, they are the warmer. They will start rising above and above into the sky. We know that whenever any air rises above into the sky, the temperature is gonna drop, because the farther away I am from the surface of the earth, the colder the temperature is gonna be. Now if these water vapors get colder, it will convert into the liquid state. Liquid state are the visible moistures into the atmosphere that are known as clouds. So as water vapor starts climbing into the sky, or as rises above into the sky, the clouds are gonna form. The clouds form is happening, that means the water vapor is getting colder, and as water vapor starts getting colder, it will convert into the liquid state. That means they have to release the heat from their body to make themselves colder, and that heat release during the process of cloud formation is known as latent heat. And surrounding the atmosphere or surrounding the cloud, the air is getting little warmer, and that process is known as condensation process. So these are the four ways through which our atmosphere starts getting heated up. What you will be required to be done, that divide your page into the 4 halves on the left hand side and draw all the diagrams that I am drawing over here. The atmosphere getting heated up due to the terrestrial radiations, write down over here terrestrial radiations, and write down conduction process. Thereafter that, the warmer air starts rising above into the sky, convection process. Thereafter that, there is another way through which we can warm the area, that is horizontal movement of air. So what you are gonna do, guys, you will draw this diagram with me into your book and write down over here advection. And when the water vapor starts climbing above into the sky, they will start getting colder and a cloud formation will happen, and this will release some heat, and that is known as a latent heat, and this process is known as condensation process. So these are the 4 ways through which our atmosphere is getting heated up. I want that you will be drawing this diagram on the left hand side of the book, so that at least you remember those diagrams, which is important for the meteorology to be understanding the future chapters. Okay, I'll eliminate this drawing that I have done right now. We'll proceed to the another topic that we need to discuss now, that is the diurnal variation of temperature. Now what is diurnal variation of temperature? In an easy way, I can explain you in terms of that the change in temperature with time, that is known as diurnal variation of temperature. Now how much change that is happening, that will define the diurnal variation of temperature, and that is high diurnal variation of temperature. Major changes are happening throughout the day, temperature is changing maximum, while low diurnal variation of temperature means less temperature change is happening into the atmosphere. Saying that, for an example, into the early morning when you wake up, the temperature was 15 degrees Celsius. By afternoon 12 o'clock or 2 o'clock into the afternoon, the temperature rised by 30 degrees Celsius, and thereafter that, back again by evening, the temperature dropped back to 15 degrees Celsius. That means what? Throughout the day, whatever the temperature was, the temperature change that happened was 15 degrees Celsius. Now let's do another scenario in terms of another day. Saying that in the early morning when you wake up, the temperature was 15 degrees Celsius. By afternoon, temperature rised by around 45 degrees Celsius. Thereafter that, back again, the temperature dropped by 15 degrees Celsius. Now today the temperature change that happened was 20 degrees Celsius. So on the first day, the temperature was changed that was happening, that is diurnal variation of temperature, 15 degrees. The another day it was 20 degrees. So that means on the 15 degree is less diurnal variation of temperature, I can say. So change in temperature with time happened less, while on the another day it happened maximum. So that means what? 20 degrees change in temperature that happened, that is maximum diurnal variation of temperature that I can say. On the another day where 15 degrees temperature was changing, I can say that it is minimum diurnal variation of temperature. Now this diurnal variation of temperature happens daily also, that is known as daily variations in temperatures. And another time that is like seasons. Many different seasons have different change in temperatures with time throughout the day, and that are known as seasonal variation or seasonal diurnal variation of temperatures that we can understand. But this change in temperature that I explained, saying that one day it was 15 degrees Celsius change in temperature happened, the other day it was happening 20 degrees Celsius. Now why that is happening, that is also one major concern to be known. Like one day it is changing less, one day it is changing more. So we need to understand that what affects the change in temperature with time, that is diurnal variation of temperature is getting affected, and we need to know the effects what those are. So diurnal variation of temperature, first it will be getting affected by the clouds. Why? Because whatever the solar radiations are coming, the solar radiations reflect the clouds, whatever those are. It reflects the solar radiations. So saying that for an example, 10 rays of solar radiations were coming. From that, only 2 solar radiations reached the Earth's surface, hit the Earth's surface, and the air above it got heated up. Because of the clouds, maximum heat was not able to come to the surface, and that is why the diurnal variation will be getting affected. Saying that during the daytime today, one day there was clouds, whatever the solar radiations are coming, those solar radiations are reflecting back again into the sky. So the heat is not able to reach. So change in temperature with time that is going to happen, that is minimum change in temperature will be able to happen when compared to a clear sky, when there will be no clouds into the atmosphere. During the night time, if the cloud has been covered, what is going to happen? Saying that for an example, this was a night time and there was a cloud. Throughout the day there was no cloud. Whatever the solar radiation came, heated up the Earth's surface, and the Earth's surface heated up the atmosphere. Now the clouds will absorb the heat, but back again it will re-radiate the heat down. And this is happening, and that is why the clouds acts like a blanket into the atmosphere, and during the cloud cover, whenever will be there will be minimum change in temperature will be happening, and it will be known as minimum diurnal variation of temperature. When there would be clear sky, it is known as maximum change in temperature will happen. So can you tell me any other reasons through which our atmosphere will be getting heated up, or saying that diurnal variation of temperature will be getting affected? Any guesses? Compared to like clouds and no clouds, we know it now. So there are many different reasons where the atmosphere will be getting heated up. Saying that for an example, coastal place or a desert place. If a coastal place will be there for an example, then at the coast the temperatures will not be able to rise more greater compared to the desert place. Desert will be absorbing the heat also, and then back again it will started getting colder also. So now we need to understand one terminology that is known as specific heat. Now what is specific heat? Specific heat is how much energy I require to make the parcel of air temperature or any material temperature to be changed by 1 degree Celsius. So to change any material temperature by 1 degree Celsius, how much heat energy I require, and that heat energy is known as specific heat. So on the left hand side, write down the definition of a specific heat, everyone. I'll dictate it to you all guys. The specific heat is that the heat energy required for temperature to be changed by 1 degree Celsius. That heat energy required is known as specific heat. So you will write down this definition on the left hand side of the book, guys, and now we will understand what happens to the desert place. Now if a desert place will be there, sand, they have more specific heat to be absorbed. That means to change the temperature of a desert place by 1 degree Celsius, they require very little heat energy, and that little heat energy will make the temperature to change very faster. So the desert place starts getting warmer faster also, and during the night time they starts getting colder faster also. So desert place will be having maximum diurnal variation of temperature when compared to water, saying that water has greater specific heat. To change the water temperature by 1 degree Celsius, we require too much of heat, and it requires more longer time also to get warmer also or to get colder also. So the coastal places specific heat will be less. So saying that, for an example, if we compare desert place and a coastal place, then coastal place will be having minimum diurnal variation of temperature, while desert places will be having maximum diurnal variation of temperature throughout the day. In desert, we know at the night the temperatures are dropped in minus also, but on the morning time or during the daytime the temperature can be varying from 45, 50, 40 degrees Celsius also. So what you can do, write it down with me. Diurnal variation of temperature first. Definition of diurnal variation of temperature is, write it down, I'll dictate for you all guys. The change in temperature with time is known as diurnal variation of temperature. This diurnal variation of temperature gets affected also. So I will write down effects of diurnal variation of temperature are what. So saying that, for an example, if clouds will be there, maximum change will happen. Clear sky, minimum diurnal variation of temperature. Thereafter, the desert place, maximum change will happen, while on the coastal places, minimum diurnal variation of temperature will happen. Any other guesses that you will be able to do where we will be able to identify the change in temperature? That is winds. If winds are blowing, then minimum change will happen. Calm winds, maximum diurnal variation of temperature will happen. Why? Saying that, for an example, winds are blowing, whatever the heat is there over here, it will take away and go away. Like this, for an example, if you see. So make sure diurnal variation of temperature, whenever the winds are blowing, the minimum change in temperature will happen. While if no winds are blowing, calm winds are there, then minimum diurnal variation of temperature will be happening. So I hope that whatever I made you write down, you must have noted down. This is the end of the topic, that is temperature. There is no further we need to understand related to temperature. So if I'll brief you about and the summary of the topic, that is temperature, what we have understood till now is this, that with an increase in height, temperature decreases, that we have understood. Thereafter, that there are 4 ways through which our atmosphere gets heated up, that is conduction, convection, advection and condensation. In condensation, the cloud formation is happening and the heat releasing, that is known as the latent heat, heats up the surrounding area also. Albedo is the amount of heat energy absorbed by a particular material. So saying that how much heat he can reflect back is known as the albedo. Specific heat of the material is the amount of heat energy required to change the temperature of a material by 1 degree Celsius. I have made you write down that also. And diurnal variation of temperature is change in temperature with time. I hope that you must have understood. Now what you will be required to be done is saying that I'll be opening a theory book to you all guys. What you will be doing, the diagrams that what I have made you draw, you will be drawing on the left hand side of the book. Okay, you will complete that part. And temperature, the definitions and the conversions I have made written down over here, that is the Celsius, Fahrenheit and Kelvin. I also have shown a diagram for the Stevenson screen. That Stevenson screen is supposed to be 4 feet above, and the different ways to calculate the temperature at the height is known as radiation. There are 4 ways through which our atmosphere starts getting heated up, that is conduction, convection, condensation and advection. Also I have made you write down. What is lapse rate, that also we have understood into the atmosphere chapter only. Lapse rate is that at what rate the temperature is decreasing with an increase in height. In standard atmosphere it is 1.98 degrees per 1000 feet. Thereafter, that isothermal layer means what? That isothermal layer is the stratosphere, first half above the tropopause layer, that is the isothermal layer, where the temperature remains constant with height. That layer is known as the isothermal layer. That is the end of the chapter. Advection and the Dundial variation of temperature definition. Please make sure that you write it down and you draw all the diagrams, whatever related to that it is. And thereafter that, what you will be required to be done is solve questions related to this chapter. So this is how your theory book look like. On the page number 38 or 39, temperature chapter topics have been available. You will require to go through this all 15 questions related to the temperature. Into the next lecture, we'll be having a discussion for the same. Thank you. Have a nice day.